Chiral molecule. Last video we have discussed chiral carbon. In this video I will be talking about the chiral molecule, and hence we will follow the sequence. What is chiral molecule? Chiral molecule. What is chiral molecule? A molecule which has non-superimposable mirror image. A molecule which has non-superimposable mirror image is known as chiral molecule. A molecule which has non-superimposable mirror image is known as chiral molecule. What is non-superimposable mirror image? The two words non-superimposable and superimposable mirror image. What does it mean? For example, if I take a molecule, a letter A, if I place a plane mirror here, plane mirror, the mirror which we used to see our face, that's I say the plane mirror. The image will be like that. Am I right? Yes. Now this is object and this is image. If I take this image and put on the object, if I take this image and put on the object, what I will see? I will see only A. If I take out this image from here and paste on the object, I will see only A, no difference. Similarly, if I take another example, if I take B, and this is the plane mirror, this is object, the image will be like that, I suppose. Am I right? Image will be like that. Now take this B image from here and paste here. How does it look like? It looks like this. It looks like this, I suppose. It's different. If you consider the case for A, this is the object, this is the image. If take out this image from here and paste on the object, we will see only A. But in case of B, the image of the B, if you take out from here and try to paste on the object, you will see like this. Two different things. Would you follow my point? This case is called superimposable, identical. Object and image is identical, but here objects and images are non-identical. Here objects and image is identical. Here objects and images are non-identical. This is like shocks. You can use shocks to any legs, left or right, there is no problem. This is like gloves. You can use right hand glove in right hand, left hand glove in left hand. Mahendra Singh Dhoni cannot use his right hand glove in left hand and left hand glove in right hand. It is specific, they are not identical. Gloves are not identical, but socks are identical. This is called superimposable mirror image. This is called non-superimposable mirror image. I can take some more example. If I consider here, suppose if I take W, this is the plane mirror. Image will be like the W. If I take this image and try to paste on the objects, it looks like same. Suppose if I take M, this is the plane mirror, this is the image. Take out this image from here and try to paste on the objects, it will be same. This is called superimposable. But here if I take example of N, this is the plane mirror, the image will be like that. This will be the image. If I take this image and try to paste on the objects, it looks different. It will be like that. I suppose it look like that. It will be like that. It will be different. This is called non-superimposable. Clear? Non-superimposable means mirror image is non-identical. Superimposable matlab mirror image is identical. And a molecule is called chiral when it has non-superimposable mirror image. A molecule is called chiral when it has non-superimposable mirror image. Clear? Very good. Let us see. If I consider this molecule, if I consider this molecule, here there is a carbon. If place a mirror here, the image will be like this. Image will be like that. This is a cloud, electron cloud. If I CH2OH and CH2OH, it is an electron cloud like that. Therefore, here is OH group in the right hand side, here OH group in the left hand side. Hydrogen left hand side, hydrogen in the right hand side. Now, if you try to take this image and try to paste on the objects, whether it is identical? No, because here in the left hand side there is hydrogen, but here left hand side there is a OH group. Here right hand side there is OH, but here right hand side there is H. Therefore, this is not identical. They are called non-superimposable mirror image. Non-superimposable mirror image. Therefore, I say this molecule is a chiral molecule. And this non-superimposable mirror image, they together are known as enantiomers. These two are isomers. They have different properties. They are called enantiomers. What is enantiomers then? Now, I can say a pair of stereo isomers which are not which are non superimposable mirror image to each other. They are called enantiomers. They are isomers. What kind of isomers? Stereoisomers. And they are non-superimposable mirror image. Then they are called enantiomers. I hope what is called superimposable, what is called non-superimposable is clear. All chiral molecule has non-superimposable mirror image, and that they are called isomers to each other, and they are called enantiomers. Clear? These two molecules are not identical, they are non-superimposable. If you take this image and try to paste on the objects, it will have a different look. Okay? Sure? Very good. This is how we can identify the chiral carbons and chiral molecules. There are some basic tricks which can help you to identify the chiral molecule. How to identify chiral molecule? How to identify chiral molecule? How to identify chiral molecule? First thing, it should have non-superimposable mirror image. Second thing, any molecule containing a single chiral carbon is always chiral. A molecule which contains more than one chiral carbon may or may not be chiral. A molecule which contains single chiral carbon is always chiral, but molecule which contains more than one chiral carbon may or may not be chiral. If it is not chiral, if it is not chiral, then it is called a meso compound. Let me explain meso compound. A molecule contains chiral carbon more than one, and molecule is not chiral. That kind of compound is called meso compound. Let me give example. The first thing, you should have idea how to find the mirror image. If it is a non-superimposable mirror image, the molecule is chiral. Second thing, that if any molecule contains a single chiral carbon, is always chiral. But if it contains more than one chiral carbon, may or may not be chiral. If it contains more than one chiral carbon and the molecule is not chiral, that kind of molecule is called meso compound. First basic thing is that it should have non-superimposable mirror image. This is the basic condition to identify a chiral molecule. Even molecule without containing chiral carbon may be chiral. Molecule without containing chiral carbon may be chiral. Molecule containing more than one chiral carbon may not be chiral. And molecule without containing chiral carbon even can be chiral. Condition is that you should have non-superimposable mirror image. I am going to give example one by one. And if a molecule contains single chiral carbon, then always chiral. But if it contains more than one chiral carbon, for example this molecule contains two chiral carbon. This is also chiral carbon, this is also chiral carbon. But if I take a mirror image, I will get this molecule. I will get this molecule. This mode of presentation is called Fischer projection. What is called? Fischer projection. This mode of presentation is called Fisher projection. Fisher projection. It is a 2D projection for a 3D molecule. Fisher projection is a 2D projection for a 3D molecules. Regarding the projection, I will make another video where I will explain each and everything. This is called Fisher projection. That vertical line, horizontal line, vertical line, horizontal line. Fisher projection. In case of Fisher projection, a molecule can be rotated about 180 degree about an axis perpendicular to the molecular plane. If I consider this board to be the molecular plane, if I consider an axis like this, perpendicular, I can rotate the molecule by 180 degree. I can rotate the molecule by 180 degree. What I want to mean, I am considering an axis like that, which is perpendicular to the molecular plane. I can rotate the molecule by 180 degree, either clockwise or anti-clockwise. There is no problem. If I rotate the molecule by 180 degree, what I will get? I will get this, I suppose. I will get this. A molecule in Fisher projection can be rotated by an angle of 180 degree about an axis perpendicular to the molecular plane, and then their configuration doesn't get changed. These two molecules are same. In a Fisher projection, a molecule can be rotated by an angle of 180 degree about an axis perpendicular to the molecular plane. Here the board I am consider the molecular plane, and this is the axis which is perpendicular to the molecular plane. I can rotate the molecule by 180 degree, either clockwise or anti-clockwise direction. Then their configuration remains the same. That means these two molecules is the same molecule. Clear? Therefore, apparently if I see this image and these objects is not superimpossible. But if I see this configuration, I am telling these two are identical. Apparently this is non-superimpossible, but this one, if you consider, it is superimpossible. This one, if you take this and try to paste here, it becomes superimpossible. What I say, that a molecule in Fisher projection, please keep in mind, Fisher projection is a 2D projection for 3D molecule. A molecule in Fisher projection can be rotated about an axis perpendicular to the molecular plane by an angle of 180 degree, either clockwise or anti-clockwise. Then symmetry of the molecule remains the same. That means both of them are identical. Now, if this one or this one, any one, is superimpossible with the object, either this one or this one, both of them are identical. If any one of these is superimpossible on the objects, then as a whole I say the molecule is superimpossible to each other and it is not chiral. Either this one or this one, any one, if it is superimpossible on the objects, the molecule is not chiral. Here this is not superimpossible, but this one is superimpossible. If you take this and try to paste here, it looks same. Therefore this molecule, though contains chiral carbon, is not chiral. This molecule I say the meso compound. This molecule I say the meso compound. There is a chiral carbon, but molecule is not chiral because it is superimpossible mirror image. This is called meso compound. That means here this one, all three are identical. All meso compounds has mirror image are identical. This here, out of these three, all three are identical. This kind of compound is called meso compound. Clear? One more shortcut is that to identify the meso compound. Here if you consider this molecule, if you consider plane like this, I suppose This plane divide the molecule into two equal halves. This part and this part, I suppose equal halves. This molecule can be divided into two equal halves. Meso compound has plane of symmetry. This plane can divide the molecule into two equal halves. That's why all meso compound contains plane of symmetry. An imaginary plane which can divide the molecule into two equal halves, where each half is mirror image to each other. They are called plane of symmetry. All meso compound has plane of symmetry. Okay, clear? Last case, molecule doesn't contain chiral carbon, but molecule is chiral. I am going to give an example. Molecule without containing chiral carbon can be also chiral. For example, if I consider this molecule, 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 this molecule, this molecule, here this is back of the plane, this is above the plane. This molecule, if I want to take mirror image, if I want to take mirror image, if I want to take mirror image, I will be getting like this. If I want to take mirror image, I will be getting like this. I will be getting like this. I will be getting like this. The bond which is below the plane in the image will be above the plane, and the bond which is above the plane will go below the plane. Now, if I want to take this molecule and try to paste on the objects, is it superimposable? If I take this and try to paste on this, is it superimposable? No. If I take this and try to impose here, it looks different. This hydrogen is on the plane, but this hydrogen is above the plane. This deuterium is below the plane, but this deuterium is on the plane. Therefore, they are not superimposable mirror images. But here there is no chiral carbon even. This kind of molecule doesn't contain chiral carbon, but it do not have mirror image to each other. They are non-superimposable mirror images. This is the example where a molecule may be chiral without chiral carbons. We will continue. Thank you.